Are you concerned about missing critical information that could advance your understanding of cellular communication? Don't let valuable insights into peptide mechanisms for dermal studies pass you by. Today, we're diving deep into the intricate world of peptides for research, exploring their functions, methods for combining them in laboratory studies, and crucial safety considerations for experimental work. This foundational knowledge is vital for optimizing your research protocols and advancing discovery in this dynamic field. Tune in for essential data that empowers your next experimental design. Dermal systems constantly communicate. Peptides, short amino acid chains, support targeted biological instructions within cellular networks. They function as tiny messengers, guiding cellular repair, modulating inflammation, and encouraging structural firmness in experimental models. Proteins are far larger and more complex. Think of them as extensive biological structures compared to concise peptide sequences. Their smaller size allows peptides to penetrate biological barriers more effectively when well formulated for study. The concept of peptide stacking gained traction for creating customized research protocols. Stacking involves combining several peptide formulations, each supporting a different biological pathway simultaneously. The objective is to create a synergistic team, enhancing overall experimental outcomes and observable effects. Dr. Prachibi Bodke emphasizes that each peptide typically supports one function within biological systems. Combining different peptides offers multifaceted support, leading to observed improvements in cellular characteristics. However, balance is crucial. Excessive active compounds might reduce efficacy or interfere with observations. The quality and compatibility of formulations matter more than the sheer quantity of peptides used. Understanding peptide categories simplifies the design of safe and effective research protocols. Signal peptides communicate with cells, encouraging the increased production of collagen and elastin proteins. These proteins are essential for maintaining the structural integrity and firmness of biological tissues under study. Matrixyl 3000, for instance, mimics collagen fragments, prompting self-repair mechanisms in research models. Studies suggest its regular use can positively influence observable markers of cellular aging in dermal systems. Further scientific exploration is readily available on platforms like PubMed for in-depth understanding. Fascinating, isn't it? Understanding these fundamental peptide mechanisms paves the way for advanced research. If you're eager for even more insights, make sure you follow me, Alara Vance, for specialized science updates and deep dives. And of course, check out Peptides Today for all general peptide news and industry breakthroughs. We're about to delve into the exciting categories of peptides and how researchers approach combining them. Don't go anywhere. The next phase of discovery awaits. Carrier peptides transport trace minerals, such as copper, vital for cellular healing and elasticity. Copper peptides, or GHKQ, support collagen synthesis, offer anti-inflammatory properties, and influence scar tissue remodeling. For comprehensive ingredient breakdowns, resources like INCD Coder provide valuable summaries for researchers. Strong acids or low pH compounds may interfere with some copper peptide formulas. Verify compatibility. Neurotransmitter-inhibiting peptides modulate expression markers by attenuating neurological signals driving contractions. Argilareline, or acetyl-hexapeptide 8, offers a gentle smoothing effect, distinct from injectable interventions. Research observations note a softening of forehead and ocular region contraction markers with consistent application. Enzyme-inhibiting peptides regulate enzyme activity, impacting collagen, elastin degradation, or pigmentation pathways. Oligopeptide 68 is investigated in luminosity-enhancing formulations and helps modulate uneven pigmentation. Acetyl tetrapeptide 40 is studied in soothing formulations and helps attenuate markers of redness and irritation. Here are 3 research-inspired combinations for building effective peptide protocols. For collagen synthesis and structural fortification, consider Matrixyl 3000 with argireline serum. For cellular repair and barrier integrity, combine copper peptides with palmitoyl tripeptide 1 for comprehensive support. A luminosity and soothing response stack could include oligopeptide 68 and acetyl tetrapeptide 40. Introduce one new peptide at a time and allow experimental systems adequate observation periods. This mitigates adverse responses and clarifies optimal parameters for specific biological models. Peptides are powerful but require careful methodological application in any research setting. As we wrap up today's deep dive, remember the immense potential of peptides to unlock new understandings in biological communication. Your ongoing research journey can uncover incredible insights, empowering discovery in the lab. Keep exploring, innovating, and applying these principles to your scientific work. Make sure to follow me, Alara Vance, for more specialized insights, and stay connected with Peptides Today for all the latest research news. Before we sign off, a quick legal disclaimer. This podcast is for informational purposes only and is not medical advice. All compounds discussed are for research use only and not for human consumption. Always consult a licensed healthcare provider for medical needs and treatment.